Okay, here we are again. So thanks for joining me. Thanks for putting up with the awkward situation of me missing the first week of classes. So this is video 2 associated with day 1. We're going to jump into the course material. I'm going to be going through some slides which you can find on Canvas. Let me pull those up here. Okay, so you should be seeing the slides, and again, these are posted on Canvas. We're going to dive into the initial material of the course. So what we're going to be doing is we're going to be talking about this simple linear regression model. We'll talk about the model itself, and then we'll talk about estimation of it. So here's my name. These slides are prepared by me, but only sort of. These are, as I said during the first video, this is the first time I have taught this class. So I have taken the slides from previous instructors and have adapted them. But this is a very much collaborative work or work from instructors that's been compiled over the years. Okay, so let's go ahead and jump in. This is how I start every one of my classes. And as you can see right away, my artistic ability is limited. But this is a way that I think is useful for thinking about statistics broadly. On the right, we have the real world, or at least my best artistic rendition of the real world. This should look vaguely like North America and South America. Here's Cuba, here's Europe. And then over here we have the math world. And the cartoon picture here is that the math world is a simplification of the real world. We use the math world to describe what goes on over here, but it's a simplification. So we as statisticians work with real data. And so the real data, of course, comes from the real world. These may be measurements about trees in a forest. These may be blood work of patients in a clinical trial. But the data comes from the real world. What we do in statistics, or what we really do a lot in statistics classes, is we live over here in the math world. And basically what we do is we use, this is supposed to be a bridge between the two worlds. What we do is we take the stuff over here in the math world, we carry it across, or more likely what we really do is we take the data that starts over the real world, we carry it across this bridge, we make some assumptions, and then we say, well, let's use this simplification to describe things. So in my lecture format, I will often reply to Mathland and the real world. And so it's useful to think about these two things. What lives over here in math world? And we already said in the real world, data lives over here. Well, in the math world, the models live here. So the simple linear regression model that we're going to learn about here in a little while, it looks something like this. We've got yi equals beta xi plus epsilon. We can zoom in here. Well, I guess I can't zoom in on the Zoom. Well, we have yi equals beta naught plus beta 1 xi plus epsilon I. And we assume that the epsilon i's are independent and identically distributed. We'll assume that they have a common mean mu. We'll assume that they have a common variance sigma squared. We're in Mathland. We're not in the real world. What we're hoping is that this is a useful model for describing something over here in the real world. But we don't really believe that the data follows this model exactly. What we think is that this model is useful it's a useful model, it's a useful description. If we estimate the beta naught and the beta 1, we try to make sense of those things. But we had to do that, we have to carry the data across this bridge over here to Mathland. The other thing we can do in Mathland, and the thing we love to do in stats courses, and particularly in stat course like 640 or 530 that you'll take in the spring, we like to prove things. So for instance, if we take the assumptions of this simple linear model a little bit further, if we further assume that the errors have a normal distribution, so notice that wasn't stated here, but we're taking it further. Up here, we just said they've got a common mean and a common variance, but we haven't said anything about the shape of the distribution, really. If we further assume that they're normal, then our test statistic associated with testing, making inference on the beta 1, the slope parameter, we can prove that that has a t-distribution. Student's t-distribution, William Gossett proved that way back. And so where does that live? That lives over here in Mathland. That is not truth about the data, but if our model were true, if we assume that, and we kind of say, hey, we're in Mathland, then that t-distribution is right. But it's all based on that assumption. It's all based on carrying this thing over the bridge. And maybe that assumption's wrong, so we got to check it. That one of the things a good statistician does is they check to see if the assumptions that they've made make sense, or at least if there's not clear evidence that the assumptions are overwhelmingly stupid. So so in stats classes, we spend most of our time here talking about models, talking about their properties, proving things. We take some data that I will provide for you. You'll apply a model, you'll check it and things. You're going to spend most of your time over here. As a practicing statistician, however, you spend really most of your time over here. And that's kind of weird, but that's what these next slides are going to be talking about. They're going to talk about statistical practice. So let's jump forward here. I have this labeled Chapter 0, Practicing Statistics in the Real World. The reason I call it Chapter 0 here is because this does not appear in the book, but I think it's very important to talk about, and I wanted to spend a few slides talking about it. So this real world piece that I was talking about is super important. It's hard to do. It's even harder to teach. Most classes spend very little time on the statistical practice. We spend our time over in Mathland talking about models and properties. And this class is very much going to spend its time pretty much in Mathland, developing the properties of these models. Our book, which we'll refer to as KNNL, skips this entirely. So as I said, there's no chapters, there's nothing in the book that corresponds with Chapter 0. The class or the classes that teach this statistical practice are Stat 555 and 556. These are the consulting classes that the department has. And they're really just essential for a practicing statistician. So I haven't told you what this is, but I've told you that it's important, it's hard to do, it's really hard to teach. And generally, it takes more time than the analysis. So what I was saying before was a statistician in real life spends a whole lot of time over here in the real world. In class, we spend a whole lot of time in the math world. So let's talk a little bit about what this is. The practicing statistician, the way that I have it here in the notes is I've broken it down into 4 pieces, and these are 4 nice pieces, but I'm not pretending that this is the whole picture. But an important part is study design. You do that initially, then there's data collection. Then you analyze the data, and that's sort of when we take that bridge or take that data and carry it across the bridge to some model, and then we draw a conclusion about it. So let's talk a little bit more about each of these. the study design is done before you collect your data. And so as a practicing statistician, you're part of a team. And so there is a question that needs to be studied. It might be, is this drug effective at treating schizophrenia? It could be, do we have evidence that that climate change is affecting the tree growth in Rocky Mountain National Park? And so you as a statistician are not going to be working alone. You're going to be working with medical researchers and with that drug question. You'll be working with scientists and government officials. If you're working with the Rocky Mountain National Park, you're going to be part of a team, and you're going to talk about the questions that you want to be answered. You're going to talk about how you gather the data, collect the data, where you, or if the data are available. Maybe you're going to be looking at satellite images for over time, talking about tree growth. You're going to be talking about subject matter, talking with subject matter experts. You're going to talk about, you oftentimes today that the data sources are huge, and so you're going to be working with people who handle the database of information. You'll be talking about programmers. It's, as the statistician, it's absolutely essential that you understand the background of a study. And so you need to be going into these meetings asking questions with a sense of curiosity, trying to understand things. And people are going to be talking about things in a language that doesn't make sense, and you're going to have to turn around and say, okay, what I'm hearing is that the response variable is going to be this. This is what we're going to be measuring to see if tree growth is changing. And that's, you got to be really specific about that. Or is that going to be people going out into the forest with basically tape measures and looking at the how thick the trees are? Is this going to be some measurement from a satellite? So anyway, study design is done before the data are collected, and usually takes a lot of time, and you got to bring a lot of people in and learn to speak each other's language. We talked a little bit about this, but really you need to, as the statistician, you need to be understanding the objectives. You need to help shape that expectation. People are going to think that you can perform miracles with data, and it just doesn't work that way. I think you need to convey what kind of data is, what kind of data needs to be collected. You need to be very specific about that. You need to have some idea of how much data is collected. In a drug study, you need to set the number of people that are going to be in the treatment and in the control groups. And so you need to know something about how variable that you expect the measurements to be. And you may need to suggest new avenues for research. What the people that you're working with may have unrealistic expectations, and you might say, well, here's what I think we can really do with the data that you're proposing to collect. Okay, and then you'll be thinking ahead. You still haven't even gathered the data, but you'll be thinking ahead about the time, the type of analysis that you will be doing. And so you want to think about the study design. If this is experimental design, you'll talk about how you're going to run the random sampling. You're going to talk about how you're going to assign people to different treatment groups. You might talk about blocking and things like that. You're going to have to, from the conversations, you're going to need to understand whether you're really designing an experiment where you're putting people into, or subjects into different groups, or if this is survey data, if this is something that's that you're just collecting from people who are not assigned to different groups. If it's and then, you know, as I talked about a little bit before, you're going to need to talk about things about sample size. Data collection can be really expensive, and so there may be pushback against trying to go out and collect 10,000 samples. So then the second bullet, we said there were 4 pieces associated with kind of this statistics in practice. So we talked about study design, that's done before the data are collected. And then you decide what data are going to collect, and people go out and collect it. Data collection is often very time consuming, it's often very labor intensive, it's often very expensive, or at least it used to be. The reason I threw the parenthetical statement in there is the field of statistics is changing very rapidly right now because we have lots of sources of very cheap data. That very cheap data is often not exactly targeted at what we want, and then making sense of that can be very challenging too. But often in kind of classical settings, especially where you got kind of study design, data is really expensive, and a lot of statistics is built on how do you make decisions, how do you learn things when the data is when you have a relatively small pile of data to work with. And then, well, nothing in life goes as planned, and that's true of statistical studies as well. You design a study, you set up your sample size, and then you have to deal with what you actually get. Sometimes people won't respond, or there are missing values. There could be a cloud that passes between you and Rocky Mountain National Park. And so if you were doing daily measurements, which probably doesn't make sense for the tree situation, but satellites have limited coverage, and sometimes clouds get in the way, and you got to deal with that. So what do you do about that? Well, you may have to make adjustments. You may have to think about getting other sources of data, or just what you can glean from the data that you get. Data management is a huge issue. There's the data entry, there's coding, there are coding mistakes. There's, if you're pulling in information from different data sources, there's alignment of data and misalignment of data. And I think the most important bullet on this whole slide is that it's often a huge task. Cleaning up the data to get it to a place where you can run an analysis is often huge, and it's often you, the statistician's job. Okay, and then finally we get to the data analysis. And that's a lot of what we're gonna talk about in this class. We're gonna fit a model. We're gonna estimate some parameters. We're gonna say, hey, here's how we interpret those parameters. We'll run some tests. We'll say that the slope is significantly different from 0 in our simple linear regression model. But in fact, everything that I talked about is kind of after the fact, and what a lot of the story is often done by practicing statisticians is done with experimental data analysis. So this is where you draw some pictures, you make some summary statistics, and oftentimes the story really is told by these methods. You draw some pictures, and then people start to understand what's going on, and then you do your analysis and you say, okay, that slope we were seeing, yeah, it really is significant, or maybe it's not significant because of the level of error that we're seeing in the data. So don't forget, just like I'm trying to say, you know, study design and data collection is going to be part of your job as a practicing statistician. Exploratory data analysis is going to be part of your job as a practicing statistician. You should be thinking every step of the way, how am I going to tell the story that I want to tell? People are not going to be impressed if you come in and say, well, this F statistic is significant, and so of course they're not going to understand it. your job as statistician will be to communicate these ideas. So this is kind of talking about fitting that statistical model. You formulate the problem that you talked about in the study design in terms of statistical, in statistical terms. Is the drug effective? Is it showing better results than the current drug? How do you write a statistical model that can address that question? So that's where you develop the statistical model, and then here's where you got to test it. You got to see if the model is appropriate, and if it's if the fit is good. So what I mean by that, where hopefully the connection you're making there is, hey, guess what? What we did was we started with data over here in the real world. We carried it across the bridge. We made an assumption about a model. We said, hey, we're going to fit a simple linear model to this data. Well, that data doesn't really arise from a simple linear model, and maybe that model that you've chosen is really poorly suited for describing that data, and so you need to check that model fit. Finally, you conclude with the hypothesis testing or the estimation and the prediction. And I guess I said finally you conclude with it, but you don't really, because then you turn around and you say, okay, here's the story. Here's the story that we set out to investigate. Here's what we saw in the pictures that I drew. Here's the pictures that we saw in the exploratory data analysis. And then here is and here are the conclusions based on the statistical model that we fit. Oh, and by the way, that model that we fit, we showed that it was appropriate, that it was a good enough model for answering the questions that we wanted to answer. All conclusions come with a measure of uncertainty. As statisticians, we're going to give a confidence interval. We're going to give a p-value associated with our tests, so that we are clearly conveying how much information that data gave us about this story that we're trying to tell. And then perhaps the hardest part is explaining the implications in plain language. And if you can't do that as a statistician, things are going to be difficult. So in the end, you can help the team make a decision. And there are kind of three general beliefs. You can change the beliefs, you can alter the status quo. Yes, we think this drug we tested does a better job, so we're going to advocate for replacing the current treatment method. You can take no further action. Hey, the drug we're testing is not more effective, and therefore we need to abandon that course of action. Or it can be collect more information. Hey, it's ready. We're ready to move on to the next phase of our clinical trial. All right, so next we're going to talk about exploratory data analysis, but let me just go back to this. So I talked a little bit about practicing statistics in the real world, and it is super important. If you're going to spend a lot more time going through the steps that I just did in 10 minutes in a video than you are going to be doing when you fit your statistical model. The stuff that we breeze through in these first few slides is really, really hard to do. It's really, really hard to talk to people who aren't statisticians about what you're doing. And it's hard to teach, and so that's why we're only doing it in a few slides. So it is taught in this, we have a special course which is designed to teach these skills. The consulting sequence does this. The time we're spending on it in these slides is completely inadequate for what you'll really do out there as a practicing statistician. Okay, I'm going to stop this video here. The next video we'll talk about exploratory data analysis, and then we will move on to the simple linear regression model.